Okay, so exercise 10E question 2, we're told we've got two particles, given the mass of particle P but not the mass of particle M. We're told this time they're connected by a rod rather than a string. Smooth means I don't need to worry about friction. And then I'm given information about the force that's applied to Q and the acceleration that they're moving with. So first thing I want to do is get that sketched out. So I've got P and Q connected by a light inextensible rod. There is a 60 Newton force applied to Q, and then it says in a direction towards P, and that is causing them to move the constant acceleration of 2 meters a second. I'm told the mass of P is 20 kilograms, so its weight is 20 g. I'm not told the mass of Q, they're just calling that M, so its weight is mg. And then there's thrust in the rod. So the rod is going to be pushing P along and working against the 60 newtons on Q, and those two values of thrust will be the same, so they will cancel each other out. So to answer part A, where I need to find the mass of Q, I'm going to model the whole thing as one single body. So if I use F equals ma, and I'm going to use the left as positive because that's the direction it's moving in. So the total force to the left is just the 60 newtons because the two thrusts are going to cancel each other out. So I've got a resultant force of 60 newtons to the left, and that equals the mass, and I'm doing the total mass, so that's 20 kilograms plus m kilograms, and that gets multiplied by acceleration, which I know is 2. So if I just simplify all that, so multiply out those brackets, subtract the 40, I end up with m as 10 kilograms. I always include the units, and that, as far as I can tell, that seems like quite a reasonable answer. Okay, then I need, so that's my answer to part M. Then I need the thrust in the rod. So I can look either at P or at Q as separate objects, and either would be absolutely fine. So let's look at P. So particle P, because the benefit of looking at P is if I've got the mass wrong, this is not going to affect my answer to P because I knew the mass of P was 20 kilograms, and that's being pushed along by the thrust in the rod. And I know from the question that it's accelerating at 2 meters a second. So if I use, 2 meters a second squared. So if I use F equals ma just on P, so the only force that's actually acting directly on P is the thrust, which is what we're trying to find, and that equals the mass, which is 20 kilograms, times the acceleration, so the thrust is 14 newtons.